Right, for the first questions, most of it are pretty straightforward, and like this one you can see is 1 over 2x, so it becomes half x to the power of -1 and so on, and then just derive it using the power rule. Second one here you can see the u is 2x plus 5 and the v is the square root of 1 minus x, so using the product rule of uv you get this. No need to simplify this at all. And moving on to this one, it's a bit complicated in a way, but you should be fine. What you do is you can sort of flip this or reciprocate left and right side, so you have this y equals to this expression. And so using the quotient rule, where u is what is on top here, and then v is obviously 1 minus 2x, and just apply the quotient rule. But there's another option. You may do what some people call the cross multiplication, and so when you cross this, you have this expression, this equation rather. So derive both sides implicitly. Here this y 1 minus 2x, you have to employ the product rule, but implicitly, and you should get this. Now moving on to the second questions. This just expand this, and yeah, you should get this quadratic expression. And in part B, you may use part A to help you, but I don't think there's a need for that. Anyhow, you get this, simplify this, reach this stage, but you do need to factorize the top and the bottom, and you get this. That's what you're supposed to do. That's what you're being asked to do, to show that the whole thing can be written in as this 2x plus 1, x minus 3, and so on. And in part C, you're being asked to draw the sign diagram. Now what you do is, in drawing sign diagram, you actually need to find all the critical values. The critical values are when the function is 0, so you set this whole thing here be 0, or have written here, and 0, and you find all the values causing the function to be 0. So you have negative half and 3 from here, from the top, from the denominator, or rather numerator. And then another situation is when fx is undefined. When fx is undefined, this can be only caused by one situation, is when x minus 2 or x plus 2 is 0. And so when you see, as you see, if we add x equals to 2, so here at this bottom here, this denominator, you have the situation where 2 minus 2, this becomes 0, and the whole thing will be undefined. And that means that x equals to 2, or in this case, x equals to negative 2 will be the critical values. Form the critical values and use what you know, the technique you know, to find the sign diagram. Okay, now the next questions. You're being actually to draw, meaning that, okay, to draw representation. So this is good enough. You just draw like a short segment, straight line segment, sort of representing the tangent passing through, tangent to the curve at point x equals to 1, so somewhere here. So that's what we need. And then the next part of the questions, we have something like this. This first principle, you may use the field definition of first principles. So be careful of the workings. Here I'm using this definition of the first principles, and then to find f prime of 1. This part is where most people will get confused, so you have to be very careful when you work in this area, this part here. And so in the end, you should get x, the f prime 1 equivalent to negative half. Okay, now moving on to the fourth questions. So just make sure you read everything carefully and identify all the key values. 5 liter, and of course use this information. 1 liter is 1000 cm cube, and so on. And of course the volume of a cylinder is pi r square h. So 5000 cm cube is this, and eventually you get h equals to this. This is cm because the r square is going to be cm square. So just cancelling the units of cm, you get cm. And in part B is also pretty straightforward, but it's a bit tricky, but it's okay. The total surface area means that you take the cylinder. If you think about it, you could take the cylinder, you take both ends, opening. So that gives you the 2 times pi r square, the area of the 2 circles, and also the area of the rectangle, which basically forming the wall of the cylinder, side wall. So it's 2 pi r h. So just simplify this, substitute the h expression into this somewhere here from A, and you get this. So this is all you need to do. The next part of the questions that ask you to sketch, use the graphics calculator. You need to have the skill to graph carefully, nicely, and to show this part in the positive part of the graph. And you must at least give us the R value. This is important because using the calculator feature, identify this R value 9.27. The corresponding area might be optional, but it's no harm getting that. You can find the minimum. When you use a feature, you always get the X, the R value and A value. And so after you've done that, there's no real calculation involved. Here, just the R is identified from the graph using the graphic calculator function, and the H, this formula we actually we shown it in part A. Just sub the R value back here, and then you get H should probably approximately 18.5, and then you need to sketch this to show that you know what is going on. Now moving on to the last questions. These questions are a bit tricky, no doubt, but still, implicit differentiation, make sure you be careful about everything. The 8xy square, this is actually use a product rule, so employ the product carefully here. You should end up getting this. Here I skip certain steps, but if you're supposed to show us some of the steps, how you arrive here to get to this, and then get dy dx equal to this. But you can you might observe that there are common factors of 4. So cancelling the common factor of 4, we end up with 2y squared plus x squared and 1 minus 4xy. Of course, I think I multiply the denominator numerator by -1. So you're supposed to show that. So make sure you're really good with the implicit differentiation. Then to determine the equation of normal, well, just 3 steps thing really. First, you need to find the gradient of the normal. So you use dy dx, plug the value of x equals to 1, y equals to 1 into the expression and get -1. But of course, the gradient of normal is -1 over this value. So you get this. So in case you're not too sure, it means that it is a -1 over m. That would be the gradient of the normal. So we use that and using this -1 value. So equation normal, I'm using this formula, y minus y1 equals to m x minus x1. So the y1 x1 came from here, and then normal of course is the value of 1 that we just calculated, and so you have m y equals to x. And the last question can be a bit tricky. So what we do is now we have 2 equations. First, to show that this normal line does not meet the curve again. Well, basically it's trying to say that well, I have to illustrate this that the curve like this maybe, okay, and the point that we're talking about probably somewhere here, and the tangents of course this, but this is the normal. So our job is to show that this normal to this point here at 1 1, this normal, this more importantly, maybe give a different color, this normal, the purple or red thing, it doesn't meet the curve again. So that's what we're supposed to show. So what we do is we substitute then simultaneously, and if it does not meet the curve again, you can never, you won't able to find another answer except for x equals to 1. And let's see how that goes. So you sub that, you get a cubic. Can be tricky. However, from part B, it was given to you that 0.11 is actually a point that passed through, and in fact it is really the point, meeting point between the normal and the curve. So that implies that also this 1 1, so or x equals to 1 is a point that the curve and also the normal pass through, and implies that x minus 1 is a factor, cos x equals to 1. So I use that to form the factor. So I know then this is a factor, and just know what the quadratic is. So let me try that. I will know that the x has to be x squared, or rather 4x squared, because otherwise I won't able to get 4x cubed. This is the only way for me to multiply x and 4x squared to get 4x cubed. Similar approach used here to see that the constant is -3. Here I get -1. The only way for me to get -3 means that the other side has to be +3. So what is this number in here? And this has to be something like ax, and we do know what this a is. We can kind of guess what it is by a kind of expansion here. Now look that this is a positive x squared. That means, okay, now look, this is x squared. So what I'm going to do is I'm going to try to find ways to expand it. I'm not going to expand everything, but find ways to expand it. So here I have x. The only way I can get x squared using x is that I times it with ax, but if I expand. So I have something like ax squared. And also, if I look at now -1, okay, -1. So the only way for me to get x squared term using -1 is times it with 4x squared. So I have minus 4x squared. But what happened is, or rather what you can see here is the result is actually x squared. In other words, I know that x squared, if I expand it, it becomes x squared. It means that ax squared minus 4x is x squared. That can only mean one thing. That means a has to be 5, because then you have 5x squared minus 4x squared give you x squared. So in other words, when you kind of guess like that, you're able to factorize. By guessing, I know it's not a perfect science, but it's actually a very cool method. Now you have this. So what you need to do is, okay, I have the solution to one part of it, this one. And what we want to do is to show that the quadratic expression has, our equation rather, has no solution. Okay, to do that, it's simple. We show that discriminant of this is b squared minus 4ac, and you can guess that this is a 25 minus 4ac. That would be 4 times 4, 16. 16 times 3. Okay, that would be something like 48. Okay, so this is 25 minus 48, and no matter what it is, we just care about the sign is a negative. So in other words, we can now conclude that there's no real solution. That's how we say it. So in other words, when we solve this cubic expression here, there's only one real answer, and that's x equals to 1. But x equals to 1 really is the point given in the part B earlier. So it means that you just basically, of course, you're supposed to find that x equals to 1, because that was actually the point given to you. You're supposed to find that. But there's no other points, meaning that the curve and the normal to that point 1, 1, they do not meet again. So therefore, you just conclude that the normal does not, okay, it does not meet the curve again. So that's it. So hope you try to understand this, and all the best.